Okay, so as you're looking up here, um, we're on 3A.2. We're going to start with, there's two parts. We're on part one, exponent rules. And so for the exponent rules, you should have picked up this little half sheet. Did you guys pick up this half sheet? Yes? No? So? All right, what I would like for you to do is to take a moment and look at this half sheet. And I want you to put a star next to the rules that you knew already. So looking through the rules, take about 60 seconds, and you're going to put a star next to the rules that you already knew. All right. Raise your hand if you put a star next to two things. At least two. At least two. I hope we all had at least two. Okay. Keep your hand up for three. Keep your hand up for four. Keep your hand up for five. Hand up for six. Seven. All right. Is your hand up? Was it good? Is your hand up or down? Oh, okay. So 7 or 6 is where we stop at. All right. I'll take it. So let's kind of go through them, and hopefully you'll see that between pre-algebra and algebra 1, you should have somewhat been introduced to them over time. So to start off with the power of 1, I hope that this was one of the ones for the 2. Power of 1 rule is basically saying when there is no power present, the power is 1. Does that make sense? When there is no power present, the power is 1. Casper the friendly 1. Okay? Power of 0. Power of 0 hopefully was the number 2 that you had up. Anything and everything to the 0 power is 1. All right? Then product rule. The product rule is saying, well, you are multiplying two factors and their bases are the same. That means that you're adding their powers. Okay. The division rule is saying when you are dividing two expressions and their bases are the same, to find your answer, you're going to subtract their powers. Okay. So only one base and you're subtracting their powers. The power of a power rule, I like to call this power squared. Okay. Power of power rule is saying that when you are distributing, well, not distributing, when you're multiplying powers, you only can multiply when there's one base. Okay. Power of a product rule, that's our distribution rule. When I have a power outside parentheses, is going to distribute to every factor inside the parentheses. Okay. Power of a quotient is when I have a power outside of a fraction, it's going to distribute to every factor in the numerator and to every factor in the denominator. All right. Next, definition of a negative exponent. I like to call this an unhappy power. So when you have an unhappy power, you're just going to simply move it to make it happy. So if I am a whole number and I have a negative power, I don't want to be whole. I want to be a partial. I want to be a fraction. I want to be in the denominator. And now I'm a happy number. Okay. When this happens, when you have a negative 1 as your power, you're creating a unit fraction. Okay. A unit fraction means that it's a fraction whose numerator is 1. Okay. Any other number, it doesn't matter. If I have any n and it's negative, I'm unhappy as a whole and I want to be in the denominator. And vice versa. If I'm a negative in the denominator, I'm unhappy and I want to be in the numerator. Okay. That's simply all it means. All right. Definition of a rational exponent. A rational exponent means I'm doing double duty here. My numerator is a power. My denominator is a radical, the index of a radical. So my numerator is a power. Let me see. Zoom thingy. Okay. So my numerator is the power, meaning that That m is what I'm squaring by, cubing by, to the fourth power, to the fifth power. Your denominator is your root. So I'm taking the square root, the third root, the fourth root, the fifth root. All right. I like to get small, then go big. You can go big and then go small. It doesn't really matter. It just means that two things are happening. You're going to be taking the power and you're going to be taking a root. Last property was common base, which we talked about last week in our 3A.1 notes, is that if the base are the same, then to solve, all you're doing is taking the powers and setting them equal to each other. If the bases are the same, all you have to do is take the powers and set them equal to one another. All right. So these are all of our rules that we're going to be using. All right. I'm going to be referring to them by words, but if it helps you to have them numbered, you can go through and number them so that as I'm marking what I'm using to evaluate, it may be easier for you. Like, okay, that was number 1, number 2, number 3, number 4, instead of writing the words out. But I'll be writing the words out. But I know that if you are a person who's like, okay, I'm going to call this rule 1, rule 2, rule 3, whatever, it may be faster and easier for you to reference back to. All right. Okay, so let's dive in. In order to simplify, this is not written in your notes, it's just kind of more of a general statement. You need to make sure that you have eliminated parentheses. So all parentheses have been addressed. If I need to distribute, I've distributed. If I need to combine, I've combined, okay? Next, the goal is to condense. When you're simplifying, the goal is to condense. Get rid of all unnecessary variables, terms, symbols, and get it down to small. All right. Smallest possible amount of characters. All right. So let's start here. So I have made you guys like a booklet of possible problems. Now, there's infinite many problems that can use any of these rules, but I made you a little booklet so it should fold and turn into a little booklet of practice problems for simplifying using exponent rules. If I print it upside down, my bad. The copier did it. Don't blame me. Yep. Just trust the process. It's a book to keep you on your toes. Okay. All right. So what we're going to do is we're going to identify what rules we're following, and then we're going to apply those rules, and we're going to simplify. Capiche? So up first here, we have -4 times -4 to the third. What rule am I following here? Art, what'd you say? It's just, we're going to use product. Yep. I don't know why I wrote proud. I'm proud to solve this problem. That's why. Product. So we're using the product rule. The product rule says that when your bases are the same for the factors, you're going to add their powers. Does that make sense? All right. The other rule after you is the rule of 1, power of 1. I don't know why I can't write a W. Let's try that again. P-O-W-E-R. So we're going to use power of 1 because there's no power present. So that means it's a 1. So I'm using two things here. I'm going to be using the product and I'm using power of 1. My base is -4. I have 1 and 3. So 1 and that's a real big plus sign. We're going to roll with it. 1 and 3. Does that make sense? What we did? Following the rule? My pen got a little carried away. It's PowerPoint problem, not me. 1 plus 3 is 4. So we're evaluating -4 to the 4. So you're asking yourself, what is -4 times -4 times -4 times -4? You only can multiply two things at a time. So a negative times a negative is a positive. And then what is 16 times 16? $256. Huh? What be negative? A negative times a negative is a positive. And I have two pairs of negatives, so they're going to turn into positives. All right. On number 2, which rule am I using? Oh, my power's not negative. Power of power. Power. Power of power. Like we're going to call it power squared. Meaning that I only have one base, which means that I'm going to multiply the two powers together. So I'm left with negative 3 to the 6. So I asking myself, what is negative 3 times negative 3 times negative 3 times negative 3 times? I'm going to squeeze it in there. There we go. And you only can multiply two things at a time. So a negative times a negative is a positive. A negative times a negative is a positive. And a negative times a negative is a positive. 9 times 9 is 81 times 9 is 729. So far, how do we feel about using these rules? Doable? All right. Let's go on to number 3. What rule am I using for 3? Power of product. Good job. This is power of product, which means that I'm taking the power and I'm distributing it to every exponent. So that leaves me with what? What's 2 times 2? So that leaves me with 3 to the 4, x to the 4, and y to the 2. You're going to always evaluate numbers. What is 3 to the 4? 3 times 3 times 3 times 3. Looking back at your other problem. What'd you say? 81. There's no more unnecessary parentheses. There's nothing else I can combine. There's no numbers I can not evaluate, simplify. All right. Number 4. What rule are we going to use here? We could use definition of negative exponent. That means we would turn the 4 into a, if we chose that, that is an option. Is that our only option? It's not our only option. What's another option? Division, quotient. You also can use it as a quotient. Remember, when you have a whole number, it can turn into a fraction and it multiplies. So this becomes m7 over m to the 4, which means now that I can use my quotient rule. And what does the quotient rule tell me? What does the quotient rule tell me? Where quotient rule tells me, so right here, division rule, this is your quotient rule. Remember, quotient means to divide. So whether I say quotient or division, it's you're subtracting. So that's power of quotient, that's the distribution. The division or quotient rule means that you have the same base in the numerator, same base in the denominator, and you're going to subtract their powers. Do I have the same base in the numerator and denominator? M and M. So I'm subtracting their powers. And what is 7 minus 4? So my final answer is m to the 3rd. We use division. The work quotient is the same thing for division. These are interchangeable. The solution to a division problem is called a quotient. All right. Let's take a little sneak peek at 5. Have you noticed that they're progressively getting harder? Okay, let's check it. All right. What are we doing here? Power of product. It's a lot to do. So here we go. So I have to distribute this. You're getting it, and you're gonna get it. So I'm gonna do it in parts so that you can see it. So we have 3x squared times xy squared plus 2y squared times xy squared. Does that make sense? So we have to distribute. That's just regular distribution, like good old Algebra Uno distribution. Now, the reason why it's not power of product is because the power is not on the outside, is it? It's just product. Just a product rule. All right, so let's start combining. When you are combining, you're doing it term by term. So you're only going to look at this term, and then you're going to evaluate this term, okay? They're separated by a plus sign, which means that they cannot become friends unless they have the exact same variables. If their variables are not exactly the same, they cannot be friends, okay? In this case, unfortunately, math believes in segregation. So here we are. Yeah. All right, 3. Does 3 have a friend in the yellow? Nope. All right. X. How many X's do I got? 3. There's 2 X's here, 1 X here. So how many X's do I have? 3. And then does y squared have a friend? Nope. All right. First term is completed. Are you with me? All right, on to the second term. Does 2 have a friend? Who is 2 a friend? Where's another number at? There's no other number. Just 2 by itself. 2. Now we're on to y. Does y have a friend? Yes. I have how many y's here? And how many y's here? So how many do I have in total? 4. 2 plus 2 is 4. And then x, does that have a friend? Nope. Are these variables exactly the same? No. So I cannot combine. So we are done. Does that make sense? The variables have to be exactly the same. That means the same number of power has to be exactly the same. If they're not, that's it. And we keep going. Okay. Now I put these two side by side because I wanted you to see the difference. This was distribution combined with product rule. Does that make sense? This is the power of product because there's a power outside the parentheses that I would be distributing on the inside. Okay. That power is 0. So really, does it matter how many times I distribute 0 to anybody? What's going to be the answer? 1. Big fat 1. Anything to the 0 power is? No matter what it is. No matter what it is. If 0 is the power, it's 1. You can go ahead and distribute your way through, but it's still going to be 1. All right. Now, 7. What am I doing? You may have to rotate your book a little bit once you open it. Just go with it. Stop that count. Which one? Product rule. Product rule means that I'm going to only combine this to have one base, right? Do not write proud again. And that one base is going to be 4. And what am I doing with the powers? Adding them. So I have y plus 2 plus 6. And what does that simplify down to? I don't know what. You know what? We'll keep going with it. Yep. I meant for it to be that big. Yep, I did. Just so you could all see it from all angles of the room. All right, I'm going to stop. I want you to do 8. A lot is happening in 8. Condense 8 down to as few factors as you can. Go. All right. I love watching y'all like process this. But the bell's gonna ring. So let's get through this. So the first thing you should have did was power of quotient. So power of quotient would have left you with A 8 over B to the 6. Next, you would have had power of product. Power of product would have left you with A6 times B to the 3rd. Remember, anything can become a fraction. All right. Next, now we're going to have our product rule. I have A to the 8 times A to the 6, which means I'm adding them together. So 8 plus 6 gives me 14. They're in the numerator, so they're being multiplied. Next, I have B to the 6 and B to the 3. One's in the numerator, one's in the denominator, which means I'm subtracting. Quotient rule. 3 minus 6 is -3. Nope. What does the -3 means? I'm what? I'm unhappy where I'm at. So if I'm unhappy in the denominator, that means I actually belong in the numerator. So your final answer is A to the 14, B to the 3rd. All right. Okay, so we're going to resume this on the next day.